I'm going to start with the topic of molecular orbital theory for polyatomic species. Alright, so molecular orbital theory, in short I have written polyatomic species. So as usual now, we start with the basics. Poly, when you talk about, so that means it is nothing but more than one. Okay, that is called as polyatomic species. So more than one can be 2, 3, 4, 5, 6, etc., etc. So if it is going to be 2, so then we call it as diatomic species. If there are 3, we call it as triatomic species. Alright, so generally in this particular part, we are going to consider the di and the triatomic species. Okay, the species can be either a molecule, a neutral molecule, or a molecular ion. Alright, so it can be di and triatomic species. That is what we are going to consider under this particular heading. So to begin with, let us first of all concentrate on the second aspect, and that is the triatomic species, this one. Okay, so to begin with, there are some steps involved, okay, in the construction of the molecular orbital diagram. Okay, and there is a method also which is to be considered. Okay, so I'll explain you step by step. Okay, and the first step we begin with, I'll start with an example. The example is, there are two cases. Case number 1, I got a molecule containing two species, A as well as B, so I call it as a diatomic molecule. Consider case number 2, I have got a molecule ABC, triatomic species. There are going to be 3 of them, that is A, B as well as C. Now if I ask you a question, okay, select the central atom in this particular species, then I'm very sure you're going to give me the answer that the central atom selection is possible in case 2. It's not possible in case 1. In case 2, yes, you can very confidently say that yes, the B is going to be at the center because A is on one side and the C is on the other side. But here neither I can say A as a central atom nor I can say B as a central atom. So I hope you understand what I mean to say over here. यहाँ पे 2 species है, यहाँ पे 3 species है, and I'm talking about the center. Center normally comes into our mind, and that is 1. Of course, there are many cases where we are going to talk about polynuclear species and all, where there are going to be more than one center, but I'm just talking about general part. That whenever we call about center, we always talk about what? 1. Okay, so whenever we consider a central atom over here, it is possible only in case number 2. Okay, that is in this case it is possible in case number 2. Okay, and here we start off with the first step, and that is selection of the central atom. So that is step number 1. So central atom generally is going to be 1. Alright, and in a molecule we are going to consider that particular species whose proportion is 1. मतलब उसका जो प्रमाण है वो क्या है, सिर्फ और सिर्फ 1. Okay, so that is going to be considered as the central atom. ठीक है? Now, I will also give you the name of those molecules. Okay, that is to be discussed. Okay, the molecules are, first one is beryllium hydride, BH2. The second one is H2O. Water, everybody knows about this. So what did I say is, in the first step, the selection of a central atom. Okay, that is, if I want to select a central atom over here, first of all is, they are triatomic. And because they are triatomic, so that means there is a concept of central atom. Alright, I hope you understood this very well. So who's going to be the central atom? The species whose proportion is going to be what? 1. So यहाँ पर there is beryllium as well as hydrogen. Beryllium is 1 and the hydrogen are 2. So it's very obvious that in this particular molecule, beryllium is going to be the central atom. Next thing is, come over here, H2O. Oxygen is going to be 1 and the hydrogen are going to be 2. So once again it's very clear, and that is the oxygen is going to be the central atom. So here in this case beryllium is the central atom, and here in this case oxygen is the central atom. So I hope you understood the first step, the selection of the central atom. The first point to be very clear, and that is the central atom concept comes into picture when we are going to consider the triatomic species. Alright, I understood about what is the making part of this. I've given you two cases, that is first case and the second case. So it's very clear that yes, that in the second case where it is triatomic, there is a need for the selection of the central atom. Okay, next thing is how to select the central atom, and that is, as I told you, that you see the molecular formula, okay, and then find out which is that particular element whose proportion is what? 1. Again, that is going to be considered as the central atom, and I have given you the molecules also which needs to be discussed over here, and that is beryllium hydride as well as water. Okay, so it's very straightforward, and that is we are going to consider specific molecules only. It's not any random molecules. Okay, so we are going to be very much centralized, okay, with the central atom. So beryllium hydride, beryllium is going to be the central atom, and H2O, so obviously आप तो जानते ही अच्छी तरीके से कि उसमें oxygen is going to be the central atom. Alright, so this is step number 1. Now the second point is, okay, I have selected the beryllium and oxygen as the central atom. Okay, now my question is very clear, and that is, should I select beryllium and oxygen as the central atom even in absence of hydrogen atoms? अगर समझो यहाँ पर हाइड्रोजन नहीं होते, ना इधर होते हाइड्रोजन ना इधर हाइड्रोजन होते, तो भी क्या हम बोलते थे कि बेरिलियम और ऑक्सीजन सेंट्रल एटम है? जी नहीं बोलते. यस, आपकी आवाज मुझे सुनाई दे रही है यहाँ तक, ओके, क्योंकि मैं दिल से पढ़ा रहा हूँ तो दिल से मुझे सुनाई देती है ये आवाज. सो बेरिलियम और ऑक्सीजन का जो वजूद है, जो आइडेंटिटी है, okay, it is a central atom. Why? Because the hydrogen atoms are around beryllium and oxygen. Okay, so that's why the hydrogen atoms are also very important. Around them, surrounding, और एक और word है periphery. नाम तो सुना होगा आपने. Yes. So our second point is about the peripheral atoms. Okay, P-E-R-I-P-H-E-R-A-L for those who want the spelling. So it is peripheral atoms, या फिर हम simple भाषा में बोलते थे पा. Okay, ये हो गया का, ये हो गया पा. Okay, so peripheral atoms, okay, is the atom which is going to be surrounding the central atom. अब जैसे मैंने बोला है कि central atom is always going to be what? 1. So how many peripheral atoms has to be there? So the peripheral atom is simple, it is n minus 1. Now what does this n stands for? Yes, n stands for the total number of atoms in that particular molecule. Okay, जैसे मैंने आपको बोला है triatomic and tetraatomic and etc etc. So n stands for the total number of atoms in a molecule. Okay, मैं diatomic यहाँ पे नहीं consider करूँगा क्योंकि मैंने already बोल दिया कि in a diatomic case it is very difficult to find out the central atom. So this is out of the question. So we go for triatomic. Okay, centralized with respect to the syllabus part. So when you consider 3 atoms total, so n का value कितना आएगा? 3 minus 1. अब आप बोलोगे -1 क्यों किया? सिंपल है, सेंट्रल एटम. ओके, सेंट्रल एटम इज 1. सो टोटल नंबर ऑफ एटम में से एक हटा दो, दैट इज वो सेंट्रल एटम है, उसको हटा दो, दैट इज गोइंग टू गिव यू द नंबर ऑफ पेरिफेरल एटम्स. नाउ हियर आई एम बीइंग वेरी क्लियर दैट द n वैल्यू इज इक्वल टू 3. So therefore the number of peripheral atoms will be 3 minus 1. It's a very simple mathematics and that is 2. Okay, समझ में आया आप लोगों को? तो सेंट्रल एटम होगा 1, पेरिफेरल एटम्स होंगे 2. वापस से अपनी नजरें यहाँ पे लेके चाहिए इन दिस मॉलिक्यूल बेरिलियम हाइड्राइड एंड H2. ओके, यहाँ पर आप देख सकते हो हाइड्रोजन इन बोथ द केसेस आर पेरिफेरल एटम्स. और कितने हाइड्रोजन एटम्स है? 2. और वही यहाँ पर मिल गया हमें. ओके, तो ये हो गया स्टेप नंबर 2 एंड दैट इज अबाउट पेरिफेरल एटम्स. सो स्टेप नंबर 1 इज अबाउट सेंट्रल एटम. स्टेप नंबर 2 इज ऑल अबाउट पेरिफेरल एटम्स. ओके, नाउ नेक्स्ट थिंग इज when I talk about peripheral atoms, n is equal to 3, so peripheral atoms comes out to be what? 2. तो कम से कम 2 peripheral atoms तो होंगे. अब उसमें से जो यहाँ पर जो peripheral atoms लिया, that is the simplest peripheral atoms, hydrogen. हाइड्रोजन से सिंपलेस्ट और कोई हो ही नहीं सकता, बिकॉज हाइड्रोजन इज द वेरी फर्स्ट एलिमेंट ऑफ द पीरियोडिक टेबल. सो हाइड्रोजन का एटॉमिक नंबर है 1, उसका 1 इलेक्ट्रॉन है. अब इलेक्ट्रॉन है तो ऑब्वियसली ऑर्बिटल का होना जरूरी है. ओके, इफ देयर इज अ स्टूडेंट ऑब्वियसली देयर हैज टू बी अ बेंच. वरना आजकल के बच्चे आप लोग बैठोगे, आप लोग जमीन पे बैठोगे? जी नहीं, बिल्कुल नहीं. ओके, कुछ इज्जत है. सो अगर बेंच है तो ही बैठोगे. ओके, तो वैसे ही अगर स्टूडेंट्स है तो बेंच होना जरूरी है, तो अगर इलेक्ट्रॉन है तो ऑर्बिटल होना जरूरी है. सो हाइड्रोजन हैज गॉट 1 ऑर्बिटल एंड दैट इज 1s. तो एक हाइड्रोजन के पास अगर एक ऑर्बिटल है तो 2 हाइड्रोजन के पास कितना ऑर्बिटल होगा? ये तो आप जान ही चुके होंगे. एंड यस, देयर आर गोइंग टू बी 2 ऑर्बिटल्स. Okay, this is a minimum which I am talking about, and at the same time, once again, I am focusing on these two molecules itself. So we go into the next step, and that is the orbitals of peripheral atoms. Alright, ये तो जानते ही हो क्या है, बहुत धड़कता है आपका दिल. ओके, लाल से करना चाहिए था, सॉरी हो गया, थोड़ा काला दिल आ गया. ओके, सो ये लाल है. सो ऑर्बिटल्स ऑफ पेरिफेरल एटम्स विल कंबाइन. ओके, कॉम्बिनेशन होता है, प्यार होता है एक दूसरे के बीच में, तो ऑब्वियसली कॉम्बिनेशन होना जरूरी है. सो ऑर्बिटल्स ऑफ पेरिफेरल एटम्स कंबाइन एंड दैट रिजल्ट्स इन द फॉर्मेशन ऑफ ग्रुप ऑर्बिटल्स. ओके, इसको हम लोग बोलेंगे जियोस. ओके, गो नहीं, इट इज जियोस. अभी आप सोचोगे ये कहां से ग्रुप ऑर्बिटल आ गया, जब ऊपर उसने हेडिंग दिया है इट्स ऑल अबाउट मॉलिक्यूलर ऑर्बिटल, तो एकदम से ये ग्रुप ऑर्बिटल कहां से आ गया. ओके, व्हाई इज ही कॉलिंग दिस वर्ड. नाउ सबसे पहला पॉइंट इज, ओके, एंड दैट इज आई यूज द वर्ड ग्रुप ओनली व्हेन देयर आर मोर देन वन स्पीशीज. आई होप यू अंडरस्टैंड दिस. अगर एक अकेला है उसको मैं ग्रुप कहां से बोलूं. ओके, यानी वो पहला पॉइंट हो गया. तो यहां पर एक से ज्यादा है. ओके, कम से कम दो है. ओके, इससे कम तो हो ही नहीं सकता. Okay, because I'm always telling you about the simplest molecules. Alright, so कम से कम दो है, तो दो है उसमें तो हर एक के पास एक एक ऑर्बिटल है, तो एक ऑर्बिटल एक एटम का, एक ऑर्बिटल दूसरे पेरिफेरल एटम का, तो दोनों कंबाइन हो जाएंगे तो दो हो जाएंगे, और इसलिए हम लोग उसको क्या बोलते हैं, ग्रुप. अब नेक्स्ट थिंग इज, why do we not call it as a molecular orbital? Now see, I'll tell you one important thing, and that is okay, for a particular combination to be called as a molecular orbital, the condition is that the combination should involve the orbitals of each and every species involved in the molecule. थोड़ा भारी हो गया ना? Yes, मैं थोड़ा हल्का करके देता हूँ. हम molecular orbital उसी combination को बोलेंगे कि जहां पर the orbitals of each and every species are involved. Okay, suppose if I consider the molecule ABC, so I need to have a combination such that there has to be an orbital of A, there has to be an orbital of B, there has to be an orbital of C. Then that combination I will call it as what? A molecular orbital. But यहाँ पर अगर आप देखो orbitals of the peripheral atoms combine. अब तक जो भी मैंने आपको एक्सप्लेनेशन दिया उससे आपको ये तो बात समझ में आ गई होगी कि there are total two types of atoms. एक होता है central atom और दूसरा होता है peripheral atom. सेंट्रल एटम एक होता है और पेरिफेरल एटम कम से कम दो होते हैं. तो यहाँ पर the orbitals of the peripheral atoms are combining, or in other words I will say that in this particular combination the central atom orbitals are not involved. Okay, so how should I call it as a molecular orbital, my dear friends? Okay, जब सेंट्रल एटम का ऑर्बिटल ही उसमें शामिल नहीं है तो हम उसको मॉलिक्यूलर ऑर्बिटल बोल ही नहीं सकते. Alright, and that's why we need to give some different word, and therefore that word which is there is group orbitals. समझ में आया आप लोग को? Okay, so how the group orbital is formed, that is step number 3. So first is the step number 1 is selection of central atom. Okay, that is always going to be what? 1. The remaining atoms are called as what? Peripheral atoms. Okay, so it is n minus 1. Point number 3 is formation of group orbitals. How it is formed? Orbitals of the peripheral atoms will combine, resulting in the formation of what? Group orbitals. Next condition is the number of orbitals of peripheral atoms combining is equal to the number of GOs. Okay? I hope you understood this. This is very self-explanatory, and that is, as I said, that the group orbitals are going to be formed by the combination of the orbitals of the peripheral atoms. So whatever are the number of orbitals of the peripheral atoms, it's not the number of peripheral atoms, my dear friends. यहाँ पर बोल सकते हैं इस मॉलिक्यूल में, लेकिन हमेशा सब मॉलिक्यूल्स में नहीं बोल सकते, इसलिए मैं बहुत स्पेसिफिकली बोल रहा हूँ. It is the number of orbitals of the peripheral atoms. कंबाइन होते हैं, जितने ऑर्बिटल्स होंगे पेरिफेरल एटम्स के कंबाइन होते हैं उतने ही ग्रुप ऑर्बिटल्स मिलेंगे. कम से कम दो तो होना ही चाहिए, क्योंकि ये दिल का मामला है दोस्तों. ओके, तो दिल के मामले में हमेशा दो इंसान तो जुड़े हुए रहते ही, आप ये अच्छी तरीके से जानते हो. तो यहाँ पर भी कम से कम दो ऑर्बिटल होना चाहिए. So when the two orbitals combine, now how many group orbitals you get? 2. If there are going to 3 combining, that will be 3 group orbitals. If there are 4 combining, you will be getting 4 group orbitals. But once again, if I just localize myself onto these molecules, so the answer comes out to be 2. क्योंकि एक हाइड्रोजन के पास एक ऑर्बिटल है, तो 2 हाइड्रोजन के पास 2 ऑर्बिटल होंगे. So these 2 orbitals of hydrogen atoms will combine, resulting in the formation of कितना group orbitals? Oh yes, you got it right, and that is 2. Okay, so 2 orbitals of the peripheral atoms combines to give you 2 group orbitals. Alright, so this is the next step. So first step, selection of central atom. Second step, selection of the peripheral atoms, or it's very simple, and that is other than the central atom are peripheral atoms. Orbitals of peripheral atoms combine, resulting in the formation of group orbitals. And then how the group orbital numbering is being carried out? Very simple. The number of orbitals of the peripheral atoms combining, that is equal to the number of group orbitals. Okay, you getting it everything right so far? Yes. Now my dear friends, once we have understood about how the group orbitals are formed, okay, and the numbering of group orbitals, we go into the next point, and that is we talk about the wave functions of group orbitals. Now the first thing is why this comes into picture. जैसे मैंने आपको पहले ही बोला, बेंच है तो स्टूडेंट है, they are being related to each other. So similarly, orbital है तो electrons है. When you talk about electrons, my dear friends, okay, they have wave particle duality. Okay, यानी उसके पास wave properties भी है और particle properties भी है. Particle means like scattering of light. Okay, that is a particle property. Wave property. Yes, I hope you know it very well. Okay, waves कैसे जाते हैं, समुद्र के लहरें कैसे होते हैं, ये आपने देखा होगा. Okay, समुद्र किनारे गए तो होंगे. Alright, अभी आप बोलोगे लहरें देखने थोड़ी जाते हैं, जिसके साथ गए उसको देखने जाते हैं. लेकिन anyways, okay, कभी कभी तो नजरें गई होगी आपकी लहरों की तरफ, तो उस नजरों पे गई होगी तो देखो आप कैसे लहरें जाते हैं, ऊपर नीचे ऊपर नीचे. Okay, ऐसा स्ट्रेट नहीं जाते हैं. Okay, it is up and down, up and down. Alright, so यहाँ पर when you talk about group orbitals or whichever orbitals when I talk about, we are going to consider the wave properties. कौन सा प्रॉपर्टीज की बात कर रहे हैं? वेव प्रॉपर्टीज की बात करेंगे. ओके, कीप द पार्टिकल प्रॉपर्टी असाइड. राइट, सो व्हेन यू कंसीडर द वेव्स, लेट अस ट्राई टू टेक इनटू कंसीडरेशन सम बेसिक्स. ओके, और फिर हम आगे बढ़ते हैं. ओके, तो अभी हम ऊपर नीचे की बात करते हैं. तो ऊपर नीचे ये डिफाइन करने के लिए, ओके, देयर हैज टू बी सम हाइपोथेटिकल लाइन. हाइपोथेटिकल मतलब क्या? काल्पनिक. ओके, जिसके नजरिए से फिर हम बोलेंगे कि हाँ ये अपवर्ड है और ये डाउनवर्ड है. सो लेट अस कंसीडर दिस वे. एक मैं आपको एक छोटा सा एग्जांपल दे देता हूं तो आपको क्लियर हो जाएगा. ओके, यू हैव डन ऑल दीस थिंग्स इन योर लोअर क्लासेस. आई नो दिस वेरी वेल. यू आर वेरी इंटेलिजेंट स्टूडेंट्स एज माय ऑडियंस. ओके, सो I consider myself very lucky for this. But anyways, have a look at once again. Okay, एक revision type हो जाएगा आपको. So this is considered as a hypothetical line. ओके, हाइपोथेटिकल हॉरिजॉन्टल लाइन, काल्पनिक लाइन है. ओके, अब ये देखिए वेव्स है. मैं अभी नंबरिंग भी कर देता हूँ उसको. दैट इज 1 2 3 and 4. ओके, सो अकॉर्डिंगली नाउ अगर मेरे पास वो लाइन है तो अभी मैं बता सकता हूँ, I am in a position to define that 1 and 3 are going to be upward waves and 2 and 4 are downward waves. Okay, just because there is a line which is there. Alright, now next thing is, okay, by convention what we do is we give them signs. Okay, the upward waves are positive and the downward waves are negative. Okay, so this is positive, a positive wave and negative waves. Okay, now please be very clear, this positive and negative, they are nothing but signs. Okay, ये भी नहीं समझ में आ रहा है तो और मैं आपको सिंपल तरीके से बताता हूँ, directions. Okay, normally what happens is whenever we talk about plus and minus, immediately it comes into your mind, and that is what? Charges. But here these are not charges. I've used the word signs, and signs means what? Directions. Alright, so it is upward and downward. They are nothing but what? Representing directions. So positive are upward directions and the negative are nothing but downward directions. So I'm talking about these particular waves. Wave functions. Functions you know very well. Okay, and that is what? Dependence. आधारित है वो, wave के ऊपर आधारित है. Okay, इसलिए हम लोग उसको बोलते हैं फंक्शंस. आपने सुना होगा x is a function of y. Okay, so it means what? X is dependent on y. So function मतलब dependence. Alright, so we are talking about wave properties. So that's why we talk about wave functions. ठीक है? Now, those are nothing but denoted as, wave functions are denoted as what? Psi. Symbol is like this. और उसका spelling ऐसा है. P silent है दोस्तों. P psi मत बोलना उसको. It is psi. Okay, this is what is the symbol. Okay, now coming back over here is, what is the relevance of signs and charges and all? Why not it is the same? The concept becomes opposite. इसलिए यहाँ पर मैंने stress किया ये signs और directions के ऊपर. Okay, now suppose if I talk about 1 and 3, these two waves try to approach each other. Both of them are in the same direction. Okay, अगर दो इंसानों को एक ही जगह पर पहुंचने का है, okay, the destination is going to be the same, so they are going to start up, okay, together. Okay, एक साथ जाएगा. Okay, it's as simple as that. लेकिन अगर एक को एक साइड जाने का है, okay, और दूसरे को दूसरे साइड जाना है, one wants to go into the north, the other one has to go into the south, so obviously they cannot go with each other. Okay, it's simple as that. All right. So same thing is happening over here as well. Okay, so if the two waves are having the same sign, so that means they have to go in the same direction. So obviously, come on, let's go together. And when we say let's go together, तो एक strength आ जाती है, एक ताकत आ जाती है अपने आप. Okay, जब अपने साथ कोई होता है तो. Okay, so अगर पॉजिटिव और नेगेटिव है तो बोले कि नहीं मुझे तो दूसरी दिशा में जाना है, आपको अलग जगह जाकर जाना है. So obviously what हो जाता है? Oh my God, I need to go alone now. Okay, so the strength goes down. So it results in weaknesses. So opposite signs is opposite directions. Okay, so they cannot go together. They will go away from each other. I hope you're understanding now what is the difference between sign and charges. Okay, had it been charges, then it would have been opposite, positive and negative. प्यार तो होना ही था. और प्यार है तो साथ में चलेंगे. ये आप जानते हो अच्छी तरीके से. Okay, तो यहाँ पर ऐसा नहीं है. Okay, यहाँ पर signs है. तो same sign will combine with each other. फिर चाहे वो positive positive हो या negative negative. Okay, कोई लोग बोलते हैं negative negative तो नहीं चलेगा. नहीं. You have to see the signs amongst themselves. Okay, अगर 2 और 4 साथ में गया चलेगा. Okay, they will go together. Okay, 1 and 3 they will go together. But if I talk about 1 and 2, 2 and 3, okay, या फिर 3 and 4 नहीं चलेगा. Am I clear with this one? So 1 and 2, okay, नहीं चलेगा. Okay, तो दिल टूट जाएगा. Similarly for 2 and 3. Similarly for 3 and 4. Okay, all these cases it won't combine. Okay, लेकिन yes, 1 and 3 है, 2 and 4 है, साथ में जाएगा, दिल धड़कने लगेगा. Okay, combine with each other. तो यहाँ पे what will happen is the strength reduces. यहाँ पे the strength will increase. Okay, now when you talk about bonding, bonding आप सब लोग जानते हो अच्छी तरीके से. We've been learning bonding over since like last 3-4 years now. Okay, and that is it's a force of attraction. And because of that attraction, what happens is the strength increases. ये तो आपको मालूम ही है प्यार में कितनी ताकत है, सब लोग ने महसूस किया है. So force of attraction results in strength. So यहाँ पर वही force of attraction है, वही प्यार है और वही bond है और इसलिए ताकत बढ़ेगी. Okay, और इस तरीके से when I talk about a molecular orbital, okay, there are two types of molecular orbitals. One is a bonding molecular orbital and the other one is an anti-bonding molecular orbital. Okay, so bonding molecular orbital, this is going to help in the formation of bond. So it is going to result in strength. और वो strength कहाँ पर मिलेगा? यहाँ पर मिलेगा. 1 and 3 and 2 and 4 क्योंकि वहाँ पर प्यार है. Okay, तो this is resulting in BMO. Okay, bonding molecular orbital. So same signs, okay, will combine, resulting in the formation of BMO. लेकिन इधर जो है वो opposite जा रहा है. Okay, ताकत कम हो रही है. तो ताकत कम हो रही तो नफरत है. Okay, bond के खिलाफ जाएगा ये, and that's why we call it as anti-bonding molecular orbital. Okay, we call it as what? ABMO. A मतलब it is anti. Alright? Or sometimes they also call it as anti. Okay, so that is something which is opposite. Alright? So whenever the signs are opposite, they won't combine and they result in anti-bonding molecular orbital. When the signs are same, they will combine, resulting in the formation of a bonding molecular orbital. So normally these are the two ones which are actually involved in the particular process. Okay, BMO as well as ABMO. To help someone is involvement. At the same time, to oppose is also an involvement. Only difference is one is a positive involvement, the other is a negative involvement. But both the cases, they are involved in the process of bond formation. One is for and the other is against. It's very simple. I give you a very simple example, and that is in a classroom also, when a teacher is going in and taking a lecture, and then there is some activity which is to be performed. Obviously the activities generally has to be performed when the college is going on, and that is for the students. And that's why we need to take the help from the students also. Alright, so if we just enter into the classroom and say that Department of Chemistry is organizing a particular event, so please raise your hands, how many students are there to help us out? तो क्या होगा फिर इस सिचुएशन में? ओके, जितने भी बच्चे बैठे हैं वहां पर, तो कुछ बच्चे होंगे जो ऐसा हाथ उठाएंगे, सर वी आर देयर टू हेल्प यू आउट, सो इट इज फॉर, सो दैट इज व्हाट BMO. कोई बच्चे ऐसे हैं आपको देख के ऐसा बोलना चाहेंगे कि देखना भी मत हमारी तरफ. ओके, तो वो क्या हो गया? ABMO. ओके, नीचे की तरफ झुक जाएंगे. ओके, सो दे आर अगेंस्ट ऑल दिस, सो दैट इज ABMO. Like at the same time, there are some students also which are not there in the classroom at all. Okay, outstanding students, yes, you know that. Okay, so many of the times, you must also be an outstanding student for particular lectures for some reasons. Okay, so that outstanding student doesn't know anything what is happening, whether the chemistry department is organizing an event or not, nothing at all. So it's not involved in the process at all. तो उसको हम लोग बोलते हैं NBMO. यानी क्या होगा वो? Non-bonding molecular orbital. Okay, वो क्या हो जाएगा? Non-bonding molecular orbital. आई बात समझ में? Okay, so this is what you need to remember. So for bond formation, bonding molecular orbital, against bonding, so that means it is anti-bonding molecular orbital and not involved at all, and that is going to be what? Non-bonding molecular orbital. So this is what we have discussed with respect to the waves, the two types, that is BMO as well as ABMO. I have labeled this. Okay, so you understand very well which waves approach result in BMO and which waves approach resulting in what? ABMO. And the wave functions are being designed by what? Psi. So coming back to those molecules, शायद आप भूल गए रहेंगे वो molecules, वापस से मैं याद दिलाने की कोशिश करता हूँ. Beryllium hydride and H2O. In these cases we have got two peripheral atoms, orbitals also two, because one each. तो दो ग्रुप ऑर्बिटल बनेंगे, और दो ग्रुप ऑर्बिटल बनेंगे तो उनका वेव फंक्शंस फिर क्या हो जाएगा? psi1 एंड psi2. यह उनका वेव फंक्शंस हो जाएगा. आई बात समझ में? ओके, द वेव फंक्शन विल बी psi1 एंड psi2. क्लियर हुआ? ओके, नाउ नेक्स्ट थिंग इज, याद है ग्रुप ऑर्बिटल्स मैंने क्यों बोला था उनको? मैंने मॉलिक्यूलर ऑर्बिटल क्यों नहीं बोला? यस, because that combination which gives you group orbital doesn't contain the orbital of the central atom. Okay, and that's why we have called it as group orbital. Okay, molecular orbital requirement is what? Okay, the whatever species which are present in the molecule, those orbitals must be involved in the combination. तो ये group orbitals में peripheral atoms है लेकिन central atom का orbital नहीं है. तो अगर मुझे ग्रुप ऑर्बिटल को मॉलिक्यूलर ऑर्बिटल में कन्वर्ट करने का, इट्स वेरी सिंपल माय डियर फ्रेंड्स, एंड दैट इज व्हाट शुड आई डू? यस, यू गॉट द आंसर. द ऑर्बिटल ऑफ द सेंट्रल एटम को उसमें शामिल कर दो तो बन जाएगा मॉलिक्यूलर ऑर्बिटल. सो दैट मींस वी गो इनटू द फाइनल स्टेप नाउ, एंड दैट इज ग्रुप ऑर्बिटल combines with the orbital of the central atom, resulting in the formation of a molecular orbital. And then we talk about the ABMO and the BMOs and the NBMOs and all that stuff. Okay, so group orbital combines with the orbital of the central atom. Its combination now, okay, will be involving each and every species involved in the molecule, because the molecule is made up of a peripheral atom and central atom. So group orbital में peripheral atom आ गया और ये central atom आ गया, यानी इस combination में सारे species आ गए. So obviously now I call it as what? A molecular orbital. Okay, अब ये जो combination हो रहा है, ये जो combination हो रहा है ना, ये जो मैंने drill दिखाया है, okay, उसमें कुछ conditions है. Okay, there are some conditions, and the conditions is based on what? Symmetry. It is based on what? Symmetry. Symmetry का मतलब होता है there has to be what? Similarity. समानता होनी चाहिए. Okay, the signs, the shape of the orbitals has to be same. Okay, if I am going to show like this, okay, an s orbital with a positive sign, and if I am going to show a p orbital with two lobes, positive and negative, okay, and if they both of them approach each other, it's not possible because they are not symmetry, they are not similar. ओके, तो इसमें प्यार नहीं होगा, नॉट पॉसिबल. ओके, तो कॉम्बिनेशन ऑलवेज रिजल्ट्स इज गोइंग टू बी व्हाट विद रिस्पेक्ट टू व्हाट सिमिलैरिटी. तो अगर एक पॉजिटिव है और एक दूसरा भी पॉजिटिव है तो यस, प्यार जरूर होगा और क्या बनेगा, मॉलिक्यूलर ऑर्बिटल बन जाएगा. So this combination has to be based on symmetry with respect to the orbitals and with respect to the signs. Okay, then only this combination takes place and then only the molecular orbital formation takes place. जब तक ये combination नहीं होगा molecular orbital नहीं बनेगा. Alright, तो ये combination के लिए जैसे मैंने आपको बता दिया है कि there has to be the most important criteria is what? Symmetry. Symmetry नहीं समझा, similarity. नहीं समझा similarity, समानता. ओके, इसके आधार पर ये पूरा कॉम्बिनेशन हो रहा है. और इस तरीके से the entire method which I've explained you, the entire steps which I explained you, okay, those are called as nothing but SALC. ये उसका short form है. Okay, what it is? SALC. Okay, इसका full form बता दो. Yes, Symmetry Adapted Linear Combination. ओके, वापस से बोलो, सिमेट्री एडप्टेड लीनियर कॉम्बिनेशन. एडप्टेड बिकॉज इट इज बेस्ड ऑन दैट. ओके, उसके अनुसार है, समानता के अनुसार ये हुआ है. सो दैट्स व्हाई आई यूज द वर्ड सिमेट्री एडप्टेड लीनियर कॉम्बिनेशन. Now what is the meaning of this? Linear combination. The very first thing which comes to your mind, linear combination. Oh sir, it's so simple. Okay, the molecules which have a linear geometry, so that is linear combination. Okay, but here apart from that, I want you to understand one more important step ahead of that, and that is what? कि यहाँ पर जो linear combination है is nothing but it is a 1:1 ratio. यानी एक ग्रुप ऑर्बिटल सिर्फ एक ही सेंट्रल एटम ऑर्बिटल के साथ प्यार करेगा. मल्टीपल ओवरलैपिंग इज नॉट अलाउड. ओके, मैं ऑर्बिटल्स की बात कर रहा हूं दोस्तों, इंसानों की नहीं. ओके, आप जरा टेंशन में मत आइए. ओके, रिलैक्स. ओके, सो इंसानों के लिए ऐसे कुछ कंडीशन नहीं है. सो कमिंग बैक ओवर हियर इज, इन दिस केस फॉर द कंडीशन इज वन ग्रुप ऑर्बिटल हैज टू बी ओवरलैप विद ओनली वन ऑर्बिटल ऑफ द सेंट्रल एटम. समझ में आया आप लोग को? सो दैट इज 1:1 रेशियो एंड दैट इज व्हाट LC इज, दैट इज लीनियर कॉम्बिनेशन. ठीक है, तो ये पूरा जो भी स्टेप्स मैंने बताया है, ओके, उससे उस मेथोडोलॉजी को हम लोग बोलते हैं SALC मेथड, दैट इज सिमेट्री एडेप्टेड लीनियर कॉम्बिनेशन मेथड. Alright, so a quick recap for this SALC method, and that is nothing but point number 1, selection of a central atom. Central atom कितने होने चाहिए? Oh yes, it's only one. Okay, बाकी के जितने भी है those are called as peripheral atoms. Okay, so that is n-1 are peripheral atoms. Okay, the next point is the orbitals of the peripheral atoms will combine, resulting in the formation of what? Group orbitals. क्योंकि इस combination में the orbitals of the central atom are not there, so I won't use the word molecular orbital. Am I clear with this? I'll just use the word group orbitals. Point number 4 or 3, I don't remember, but the next point is okay, the orbitals of the peripheral atoms, whatever the number are, that is equal to the number of group orbitals. Okay, next is we talk about wave functions, क्योंकि यहाँ पर we are talking about the wave properties of the electrons. Okay, this is what I shown you. So those wave functions are denoted as psi. Okay, the spelling is PSI, लेकिन उसका जो उच्चार है, उसका जो pronunciation है is nothing but psi. Okay, don't say psi. Okay, and then I told you about how the wave functions are going to be considered as. Okay, there are going to be two wave functions for the molecules that are under consideration, beryllium iodide as well as water, psi1 as well as psi2. Then I explained you about the BMOs and the ABMOs and all. The same sign waves combined, it gives you BMO. The opposite sign approaches each other, it gives you what? ABMO. Now how this molecular orbital formation takes place? Very simple. Group orbital, I add into it the orbital of the central atom. It results in the formation of what? Molecular orbital. Alright? But then, ये जो combination है, okay, that has a condition, and that is there has to be a similarity. Okay, group orbital and the molecular orbital, there is to be similarity with respect to the shape of the orbital, with respect to the type of the orbital, and with respect to the sign of the orbital. Okay, and that's why the entire combination is based on what? Symmetry. Is based on what? Similarity. So symmetry adapted. And one more important thing is कि एक group orbital only and only orbital of one orbital of the central atom के साथ combine करेगा. Okay, so that's why it's linear combination, or I just use simple word is 1:1. Am I clear with this? So this is what the LC means is, and this is what the entire meaning is of symmetry adapted linear combinations. Alright, so I hope this part is absolutely clear to all of you all.